René Thom was born in Montbéliard in 1923 and is professor of the Institut des Hautes Études Scientifiques in Bure-sur-Yvette. He is without doubt the most famous living mathematician for his no less famous catastrophe theory, which was published definitively in 1972 in the book Stabilité structurelle et morphogénèse. This text spread like wildfire throughout the scientific community. A specialist in algebraic topography, in 1968 Professor Thom was awarded the Fields Medal, the sought-after Nobel Prize of Mathematicians, and in 1970 the Great Scientific Prize of Paris. With his opinions on morphogenesis, evolution and scientific thought, he keeps up interesting controversies with colleagues via specialized publications. We anticipate naturally that tomorrow's interaction with one of these colleagues cannot be avoided. Finally, the mutual admiration of Dr. Thom and our host Salvador Dalí is no secret to anyone.
Ladies and gentlemen, Mr. Chairman, I am very happy to have the chance to speak here in this exceptional setting. I have had the privilege of meeting briefly this morning with the proprietor of this place in a visit that has greatly impressed me. I should like to begin my topic here. My interest in the problem of determinism has been essentially a circumstantial interest. In these last years, there has arisen a whole epistemological school that has developed with the main purpose of refuting, in some way, the most traditional scientific certainties, particularly determinism. The idea of determinism, in the traditional sense, in the Laplacian sense of the term, has been tangibly the preferred one. What characterizes this school, some of whose branches have their origin several decades ago, I recall particularly the School of Order, by the uproar and diverse theories of self-organization that have arisen after in its wake, is a taste for negative notions. At this point, I would like to ask for my board to be brought in. What can we read here, more or less? The great concepts used in the tradition of scientific philosophy, organized essentially in pairs. Pairs that I would venture to qualify as positive and pairs that I would qualify as negative. On the positive side, we find unity, simplicity, order, permanence and determinism. On the negative side are multiplicity or diversity, complexity, change, disorder and chance.
Le changement, le désordre et le hasard.
What characterizes all these modern epistemological schools is their interest, their fascination for the concepts of the right-hand column to the detriment of the left-hand column, which in some cases appear to be the vectors of an intellectual imperialism which considers them outdated. I would like to say that I have personally experienced my own evolution, the stages of which I shall now briefly recall. When I created catastrophe theory in the 70s, in 66 to 70, I was particularly fascinated by change. The catastrophe is essentially a phenomenological change, if you will, a brutal change even. It is a change that appears immediately. It is what characterizes in some way the specific side of a form. A form is separated from its content extent, by means of a very sharp contour. And this specific character of the phenomenological change is precisely what catastrophe defines. Then I identified with the right-hand side of the board, and I considered myself an Heraclitian. I have forgotten to mention here that, obviously, we could add that amongst all the possible historical references, this is the side of Parmenides and the other that of Heraclitus. However, it is worth observing that in both Parmenides and Heraclitus, the opposition was very far from being so clear-cut, because, on the one hand, Heraclitus often mentioned the logos, that is to say, the principle of the stability of things. Everything owes its permanence to a logos that permits it to withstand continual conflicts with the environment. Obviously, this is my interpretation, and I don't know if Greek scholars would accept it, but I think there are good reasons for accepting it. On the other hand, Parmenides still found it necessary to explain change in things by means of his rejection of doxa opinion. There was opinion that believed in change in things, and those with true knowledge who recognized the permanence underlying the variability of phenomena. Therefore, at one time, I found that I was Heraclitian. Later, after intensive thinking, during the decade 1970 to 80, finally I found myself again on the side of Heraclitus. I think that catastrophe theory is fundamentally a theory that points to the reinstatement of permanence by means of apparent phenomenological change, which is totally in the tradition of Parmenides, Meyerson, and all those thinkers who have affirmed that the purpose of science is to restore unity from the apparent variability of things. All these preliminaries are quite necessary to explain the extent to which I have been able to change my opinion in this field. I would then like to deal with the problem of determinism, because I think we can look at it from various angles.
Sous différents aspects. Les partisans de cette école de la variabilité et du flou et du chaos.
Precisely another case of this opposition, a historically thrilling case, is represented by the German mathematician Hausdorff, whom you may know committed suicide in 1943.
Hausdorff, qui, peut-être vous le savez, s'est suicidé dans les années 43. Il était juif.
He was a Jew and committed suicide together with his wife. But sometime before his death, he had written a philosophical essay which was republished several years ago, and its title was Zwischen Chaos und Kosmos. And I think that here too, the opposition between chaos and cosmos is completely fundamental. The left-hand column is the column of cosmos, and the right-hand column is the one that corresponds to chaos. We already know that chaos has come back into fashion recently, but I will talk about that later. So now I come to the problem of determinism. I will skip the first few lines on my board and begin with the bottom one, which is in some ways the most complex.
On peut considérer que le déterminisme
absolute determinism, that is to say with no specification at all of the objects we are talking about, leads us to a problem that is, I would say, theological in nature.
Par exemple, on considère...
For example, if we consider that the evolution of the universe is predetermined, written somehow in the divine mind, and that basically time only develops this pre-written vision of the evolution of the universe, then we have basically theological vision that may present some power of consolidation, but has zero scientific or pragmatic interest. It is worth stating here that the advocates of absolute contingency are in no way in a better position, because affirming that phenomena are the result of chance is not much more useful than stating that they are created by the decision of a demiurge, completely free in the exercise of its will. Possibly one should see in these two conceptions the opposition between a determined world and one in which contingency is exercised freely. The eternal opposition between the two conceptions of divinity, the immanent God, bound by laws that in some way constitute him, and the transcendent God, authentically free, who exercises his will without any kind of obligation. Basically, determinism can be studied, if you so wish, in line with the three stages of Auguste Comte's philosophy: the theological, the metaphysical, and the scientific, I would say, positivist. Therefore, the metaphysical stage of determinism is precisely Leibniz's principle of sufficient reason, which states that nothing is produced without a cause. Expressed in another way, in nature, in the world, there is no absolute principle. Every principle must be linked to another previous thing that explains it. Obviously, it is a notion difficult to formalize, difficult to specify. But I think that this is a demand of the intellect from which it is difficult to escape. I am one of those people who think that to accept an absolute novelty, to accept a principle without any antecedent at all from the previous situation, is practically to open the door to what is arbitrary, to ruin any attempt at explanation, to ruin any intelligibility of things.
C'est donc la racine profonde.
Here we find the deep-seated reason of my opposition to indeterminism, in the fact that determinism is, for me, a fundamental aspect of the demand for intelligibility, and to renounce determinism is to renounce intelligibility. I believe that the price is too high. Indeed, in its journey, science moves constantly from the left-hand column to the right-hand one. To put it another way, all major scientific progress may be considered as the possibility of reducing diversity towards unity, change towards permanence, etc. Here there is something very well known. But obviously, we may wonder why, in these conditions, sometimes determinism should be questioned, as it has been recently, in this very place, in previous lectures. I think that it should be realized that determinism only acquires epistemological content, strictly scientific content, if we give expression to it in a more general framework. That is to say, we study either the universe as a whole or a system we consider isolated, and what we do is study the temporal evolution of this system. And so, in reality, there is only determinism in the scientific sense of the term, when this is temporal evolution, can be submerged in a group of virtual evolutions, and if we can expect it from this group by means of scientific, that is to say, determined criteria.
À caractère scientifique, c'est-à-dire à caractère déterminé. À mon sens,
In my opinion, the problem of determinism cannot be dealt with in abstracto, in theological or metaphysical terms,
in abstracto en termes théologiques ou métaphysiques, mais
but in scientific terms.
le déterminisme
Determinism is always tied to the existence of a continuum, of a group of virtual evolutions, from which the real evolution can be extracted by means of explicit procedures, in general mathematical procedures.
Alors, comment va-t-on constituer?
Well then, how will we constitute it? The real must be submerged in the imaginary, and the real must then be extracted from the imaginary with the aid of more or less formalized procedures, strictly formalized. When a process is determined, it is so in a unique way. Therefore, it is here that, for me, the problem of space and time appears. Time is obviously implicit in the problem of determinism, since the issue is to define temporal evolutions. But space, I think, immediately plays a part that is implicit in itself in most of the considerations of determinism.
Sur le déterminisme. Et voici comment.
We see how, in order to create a continuum of the virtual states of the universe is regarded before all else as a space. It is something extensive. And at each point of this extension, we can consider the local state of the universe.
On peut considérer l'état local de l'univers.
The local state is a notion obviously difficult to define in a general way, but we can say, to use the language of the mathematicians, that the group of local states of a universe is parametrized, like by the points of an auxiliary space, which I shall call S, and then by the local state in the universe at a point X.
L'état local d'un univers en un point X, c'est la correspondance.
So, the local state S of X at this point is the correspondence that associates to the point X. At this moment, to create a global state in the universe, the global state of the universe is considered to be the concatenation, so to speak, or the meeting of all these local states. We take the whole set of values, S of X, for all the points X at the same instant, T. In a universe in which there is a time, a global time, and then temporal evolution is the evolution of this function, S of X and T, over time. This is the general scheme of the structure of determinism, which we may call mathematicized.
Du déterminisme, disons, mathématisé.
In classical Laplacian determinism, it is assumed that these possible evolutions of a system constitute a space of finite dimension, which is the space of these states, of these initial conditions, and this space does not fully determine the temporal evolution of the system, but determines it for an arbitrary module, that is the set of initial conditions, that is to say, the initial position of the point. Here, there is a residue of indeterminism that plays a very and extremely important role in practice. Physicists, for example, systematically make use of the invariance of the laws of physics and, by contrast, tolerate high contingency on the initial conditions. And starting from current conditions, by retrodiction, we can even evaluate the state of the universe at its origin.
Évaluer l'état de l'univers à son début, n'est-ce pas, c'est tout ce qui concerne la cosmologie.
All this is subject to present-day cosmology, the Big Bang theory and so on.
Mais en général, dans la théorie générale de Laplace, on a
However, in the general theory of Laplace, we have a space of initial data, In this space, we have a vector field, when evolution is termed autonomous, and the integration of this vector field will define the possible evolutions from a given initial state. M sub 0 equals m of t sub 0 given. This model of Laplacian determinism is, in my view, something fundamental, and I do not believe any better one has been found, in the sense that it is a model of an extraordinary lightness which can be localized. If we can apply the same paradigm to a system that is relatively autonomous with respect to the rest of the universe, and we can equally define what is a weak connection between two independent systems, or evaluate the effect of a weak connection between two weakly connected systems, all this gives considerable lightness to the formalism of differential determinism. And I personally think that nothing better has been found with regard to the description of temporal evolutions. I would like to say only a few words about the recent literature on systems that present the phenomenon called sensitivity to initial conditions.
Le phénomène dit de sensitivité aux conditions initiales.
You already know that this is about differential systems, with the property whereby if two very close initial values are fixed, the trajectories diverge at the beginning quite fast, in general, exponentially, in terms of time. They are systems that, according to modern fashion, are called chaotic, and which I would personally prefer to call expansive. They are systems that extend in a certain direction, which try to compensate for this extension by contracting in other directions. Some conservative systems present this phenomenon, in particular Hamiltonian systems may do so. The phenomenon had already been observed by Poincaré, although it was Jacques Adamard who, right at the beginning of the 20th century, 1902 or 1903, expressed it clearly by means of geodesics on the surfaces of negative curvature. The phenomenon was immediately revealed by Duhem in his book on physical theory. Duhem explicitly stated that in a differential system of this type, determinism is no longer valid. And from this standpoint, the criticism of determinism took shape. Personally, I think that it is completely abusive to call these systems chaotic systems. But unfortunately, I have no chance of being listened to, since the fashion has emerged from this chaotics. This is a word which is easy on the eye. It's appealing, even though I find it completely abusive to regard as chaotic a system such as, for example, automorphism, defined by the matrix 1, 1, 1. In my view, the word chaotic ought to be reserved for systems that cannot be described, of which there are many in nature. And it ought not to be used to refer to systems that have an explicit description, above all if these systems are also structurally stable, as is the case of the automorphism I've just referred to. These chaotic systems permit short-term prediction. So, in meteorology, which is a system that presents this property, which has a sensitive dependence in respect of initial conditions, as my colleague Rouel has said, according to a famous formula that, maybe it's another one, I don't know, I can't remember.
Mon accès de toux au mois de janvier peut provoquer un cyclone tropical en septembre.
So, during the month of January, a tropical cyclone can be caused for September. But the only thing this divergence from natural conditions proves is that determinism is costly. A distinction must basically be made, from my point of view, between systems in which determinism is costly to take advantage of, and systems which lack determinism, if they exist, which is not certain.
Alors, il y a donc là une petite correction.
Here, a small correction would have to be made with regard to current conceptions. For the moment, there is no chance of understanding this, but possibly further on, an appropriate conception will appear. To finish with scientific determinism, I must say a few words on the quantum objection. The quantum objection comes obviously from a different situation. In order to be able to define determinism in scientific matters, one must necessarily postulate something similar to a continuum of virtual evolution, which is in general parametrized by a fixed space. And here we already have an enormous hypothesis, don't we? To postulate that the whole set of virtual evolutions of a system may be parametrized by a fixed space is a very substantial thing. We have various examples in dynamics, so-called symbolic dynamics, of situations in which, given the fixed space in question, we can cut it into pieces. This is called a Markov partition of the set considered. This is a dynamics which has an automorphism which keeps its volume, a conservative automorphism, and therefore, for some of these systems, I'm not insisting on these techniques, if we take a point, we can enumerate the pieces of the partition in which they fall successively, and we thus obtain a quite finite series, a lateral closure in both directions, on the left and on the right, of symbols in a finite number. These systems have this quite surprising property in which every point is characterized by its symbol. And these bilateral chains of symbols can, in this way, characterize the initial space, the space of the virtual evolutions. Therefore, we have here a quasi-tautological formula of determinism, in which temporal evolution itself is what determines, in some way, the space of configuration. And I think that, in some way, the ideal in science would be to arrive here, to reach a situation in which the problem of the definition of the space of configuration would be in some way connected with the problem of determination of temporal evolutions. Obviously, I said a few moments ago that to define the virtual evolutions of an extensive universe, the concatenation of these local states is used. To create the whole set of virtual states of a universe of this type, a global state can always be deformed. We know a global state that is assumed to have been realized. If it is deformed locally, a virtual state is obtained. And the problem at the moment is to extract from amongst all these virtual states those which are effectively realized by the system and, at the same time, the corresponding evolutions. In this way, enormous spaces are constructed. Since the space of these global states is a space defined by the function S, x, t, which I spoke of before. Therefore, we are dealing with a functional space, and you already know that functional spaces are of infinite dimension. They are enormous spaces. And it is not surprising that in these conditions, when a large space is taken out for determinism to be laid on it, an infinity of conditions also have to come about. And in this situation, the space of the initial conditions, the same space, is also of infinite dimension. And this raises many questions. Another important problem is knowing whether determinism is a local determinism. All the laws of classical dynamics, the laws of classical physics, for example, Fourier's equation for heat, the waves equation, Klein-Gordon's equation, Schrödinger's equation, etc. All these equations have been drawn from a local determinism. The local evolution of a solution is determined by what happens in the immediate proximity.
On peut dire en un certain sens que
We can say, in a certain sense, that the only determinism that makes any sense, from the point of view of application possibilities, is always a local determinism.
d'application est toujours un déterminisme local. Alors ici, bien entendu,
Therefore, here, obviously, the quantum theorists will not avoid telling me that it has all been proved by means of Bell's inequalities and aspects experiments, that quantum determinism is not local. And I think that this vision must be accepted.
je pense qu'il faut accepter cette vision, c'est vrai, il faut accepter ce fait dans l'état actuel des choses.
It is true, this fact has to be accepted within the current state of things.
Il y a un article récent de
A recent article by Bell shows that for Schrödinger's equation, we can nevertheless have a determinist theory,
d'introduire des
but with the condition of introducing parametric spaces that are not locally defined, that are defined globally in the whole space.
Alors le problème tel que je le vois dans ce
The problem, as I see it in these conditions,
diminuer
is decreasing the space of the virtual states of the universe, taking into account precisely the obligations raised by these non-local conditions.
posé par ces conditions non locales. Personnellement, ça me choque un peu, je dirais, mais ça ne...
Personally, I would say that this surprises me a little, but it does not surprise me because I have always had in mind a geometric interpretation of quantum determination. It is something very stupid.
C'est quelque chose de tout bête. Vous prenez une enveloppe de droite.
Take an environment from the right-hand side of the plane. A family on the right of the parameter. I'm speaking here for the mathematicians. I apologize to everyone else.
Varie en fonction du paramètre.
If this family varies according to the parameter, very important variations may come about in the angle on the right, of the total angle on the right, according to the parameter.
Très importante.
If this variation is very large, then the characteristic point in which the right-hand family touches its environment is well defined, with precise accuracy.
Une bonne exactitude. Au contraire, si
By contrast, if the incline on the right varies slowly, if on the right it is almost always constant, the position of the characteristic point on the right is very poorly determined. And I think that we find a very simple reason which, from my point of view, justifies, can explain, quantum indeterminism.
déterminisme quantique, c'est que les objets
This is that the fundamental physical objects are not punctual objects, as is always stated, but extensive objects.
parenthèses,
And here, please allow me to make a digression.
le rôle des symétries.
This leads to the role played by geometrical symmetries in physics.
On a toujours plaqué a priori les symétries de la géométrie sur
It has always been admitted the symmetries of geometry have always been placed over and above physical theories.
plus machien, qui consiste
Possibly one should move towards another point of view, a more, I would say, male chauvinist point of view, which would consist of saying that the symmetries in themselves have to be based on physical objects.
dans des entités physiques. Et si on
It is not normal for symmetry, which has physical effects, not to be based on physical entities. And if we accept this point of view, we reach the conclusion that physical entities may exist which do not have physical value, which are non-local in character and are, in some way, extended a priori. This shows that we need a vision of space that is a bit more complicated than our traditional one. But my God, it isn't so monstrous, though.
au fond, les
This reiterates that basically the possibilities of geometric interpretation of the world are still very far from running out.
la notion de
According to physicists, the notion of vectorial space and connection with gauge theories has just been discovered.
théorie en anglais.
Foliations have not yet been discovered, but everything has its time.
Je suis convaincu que le
I am convinced that the basic problem in quantum mechanics is the following.
c'est quand même
The same phenomenon may be seen by different observers in different ways.
Ce n'est pas particulier à
This is not particular to the quantum world. Any natural entity can be seen by observers, including classical ones, in very different ways.
de manière très différente. Le monde qui
The world here is made of people and objects.
si je me déplace,
If I move, these people change in my universe.
néanmoins je suis
But
capable
I can restore it nonetheless by the fact that in some way I can coordinate the movement of my eye with the movement of its retinal image.
avec le déplacement de son image rétinienne en quelque sorte. Il y a une loi d'holonomie
There is a law of holonomy that links the movement of the eye with the movement of the retinal image. And this law enables a criterion of objectivity to be given for the source of this appearance.
de la même manière.
Similarly, there will be laws of holonomy or quasi-holonomy that somehow form the foundation for physical objectivity.
L'objectivité physique. Il se trouve qu'en mécanique quantique que la loi n'est
In quantum mechanics, the law is not very holonomic, because when we move a point of reference in the space, P of Q, of the infinite decimal references of phase space,
il faut multiplier la fonction d'onde.
the wave function has to be multiplied by the sum of the exponentials P of Q, and this law is far from being holonomic.
Alors ça détruit
They somehow destroy the intersubjective consensus that is only valid as a level of rays and not in the wave function.
on n'y peut rien, c'est comme ça.
It is a nuisance, but nothing can be done about it. This is the way it is. And this makes me think that one day or another we will have to have mathematical structures more complicated than foliations, which, as you know, are structures defined by local projections that glue back onto each other.
Un jour ou l'autre, on arrivera à développer des modèles où un phénomène sera défini comme une...
I hope that one day models will be developed in which a phenomenon will be defined as a plaque of foliation in a vision space product by an observer position space.
dire encore quelque
Well, I will not develop this point of view any further.
un peu polémique.
I would like still to say a few words of a somewhat controversial nature about the question of chance and the existence of pure random phenomena.
Théorie de l'aléatoire pur à la suite des travaux de
Some people have held that the Kolmogorov-Chaitin theory allowed the precise definition of a chance phenomenon.
nombres entiers.
For example, a succession of whole numbers is random if every algorithm that allowed it to be generated is of a length higher than that of the succession itself. This is a definition, a crude definition, obviously, of a random succession.
D'une suite
To put it another way, a phenomenon, if a phenomenon is described in this way by means of a random succession in this sense, cannot be the whole algorithm, but permits a succession longer than the succession itself to be engendered. This means that if we try to explain the phenomenon by the generativity of the symbolic system in which it is described, no explanation is shorter than the description of the phenomenon itself.
dans un article de philosophie.
In a philosophical article in one of my books, I have defined the scientific explanation as a reduction of what is arbitrary in description.
Phénomène aléatoire au sens de Kolmogorov-Chaitin.
Even though there are random phenomena in the Kolmogorov and Chaitin sense, I would like to say that these phenomena cannot be explained. It is in this sense that all explanation would necessarily be longer and more complicated than the description itself. Obviously, there is a very strong temptation to define the random like this and to say, well, after all, there is nothing to prevent there being this type of phenomena in nature. Personally, I think that there are many difficulties in sustaining this view for the following reason. With the smallest change in the succession of whole numbers considered, this definition of what is random is not sound, because immediately nothing remains of what was formerly theorized. If from whole numbers we move to rational numbers and then to real numbers, we would immediately see that we are up against insuperable difficulties. There is no chance of defining it in a way that is reasonably sound. This suggests to me that leaps of this kind, to justify what is random in science, are difficult to defend, even if it were only for the fact that in most of the phenomena, the description itself cannot be made in a fully constructed formal system.
Entièrement construit. Alors, je voudrais dire un mot maintenant en liaison.
Now, I would like to say a few words about this impossibility of the random, a few words about novelty. This school of theorists of the change and variability of phenomena has been motivated basically by the idea that the possibility of novelty in the evolution of the universe had to be justified, in particular in biological evolution.
En particulier l'évolution biologique.
Personally, I am one of those people who believe that a radical novelty is incompatible with the scientific view of the world. That is to say, what is a radical novelty? It is a novelty that somehow is an innovation that escapes from all existing formalisms. If the novelty could be described by means of an existing formalism, it would not really be radically new. Here we may allude briefly to Borges's famous story, The Library of Babel. You know that this library contains all books, including virtual books, since nothing would prevent books being written with a series of symbols chosen, in principle, arbitrarily.
En principe, arbitrairement. Eh bien, je pense.
I think, in effect, absolutely radical novelties are impossible to find in science. Obviously, there are relative novelties. Some novelties may be phenomenological. When Tycho Brahe observed his famous supernova, it was obviously a novelty. It was a star visible in plain daylight that lasted for a certain time, which destroyed the belief in the immutability of the fixed stars, even though it was a star itself. It was not a fundamentally new concept.
Ce n'était donc pas un concept fondamentalement neuf.
Similarly, most novelties in science are novelties relative to an existing formalism. If, for example, the issue is a discrete phenomenon, like the shifting of the perihelion of Mercury in relativity theory, it is clear that this is a phenomenon that can only be visible in terms of a pre-existing theory. All this makes me think it difficult how the problem of novelty could be considered usefully in science. Obviously, the novelty sometimes is presented empirically, either as an unexpected phenomenon or as a considerable theoretical expansion. But in both cases, it can't be predicted. Science is par excellence knowledge, that is to say, a set of data that we must pass on to our descendants, just as it is, without modification. In particular, and this is a digression, we should be careful not to introduce into education all the latest novelties that are in the papers. And unfortunately, many mistakes have been made in recent times in this field, and modern mathematics is a forceful example of this.
Les mathématiques modernes en étant un exemple flagrant. il faut s'en tenir à une tradition pédagogique stricte.
We must confine ourselves to a strict pedagogical tradition and learn the essential things, the basic stuff, and not let ourselves be seduced by the latest novelties.
Le code génétique, la théorie néo-darwinienne.
Now, in biology, DNA, the genetic code, neo-Darwinist theory, etc., is taught and anatomy is no longer studied.
Sans avoir appris l'anatomie classique, on leur apprend de la biochimie.
It is said that today's doctors leave medical school without having learnt classical anatomy, and yet they are made to study biochemistry. There is always a tendency to be snared by the latest novelties. I think this is a basic mistake. In science, one should adhere to a corpus of well-established doctrines and relinquish it only when necessity demands.
Alors, l'opposition qu'on peut avoir d'ailleurs.
Any opposition we have to the introduction of novelties, and I would say even quasi-natural, in the sense that it is not within the perspective of a formal theory to foresee its own destruction, to the extent that a theory may be formalized, is coherent and, in consequence, will not manufacture an object that is strictly in conflict with it, which is strictly incompatible with it. From this standpoint, I think that novelty should be excluded, in my opinion at least, in education.
Au moins du point de vue de l'enseignement. Alors vous me direz, évidemment, il y a le problème du progrès scientifique.
Obviously, you will respond that there is the problem of scientific progress. It is true that science changes, but these changes are purely the result of new empirical exploration. They do not require basic theoretical changes. They can be absorbed with no special difficulty.
Les changements théoriques fondamentaux, ils peuvent être absorbés sans difficulté majeure. Un problème plus grave.
A more serious problem arises with theoretical extensions.
Il faut bien voir en effet.
It is worth observing, in effect, that what counts in science is the capacity of the spirit to constitute the continuums of states of the universe, starting from which, by restriction, we may define determinism.
Définir le déterminisme. Autrement dit,
In other words, it is to imagine that permits us to raise, cleanly and strictly, the problem of determinism.
alors évidemment, dans la mesure où on
Therefore, obviously, from the moment at which imaginary constructions can be extended, one can, in some sense, cause problems with regard to the corresponding extensions of determinism. And this is what has happened with quantum mechanics.
Par contre, quand les progrès scientifiques.
By contrast, when scientific progress does not make reference to the extension of the mathematical imagination, but to conceptual extensions, I believe that the progress is less notable.
On pense par exemple en biologie à la théorie Darwin.
Let us consider biology, for example. The Darwinian theory of evolution. Here, it is clear that reference is not made to really new concepts. And this fact, the Darwinian explanation of evolution, for me, has always been suspect.
Alors, pour terminer cet exposé.
To end this exposition about the definitions and the failures of determinism, I should like to say simply that, in science, the problem of determinism is raised only in terms of canonical procedures, of the extension of the real into a larger virtual realm.
Extension du réel dans un virtuel plus grand. Et
And the big problem now is the precise definition of these canonical extensions of the real into a set of virtual states.
On a toujours trop vite fait de dire.
It has been affirmed, always in too much of a hurry, that determinism is failing. And for me, what is failing is our imagination. The failures of determinism are failures of our imagination, and there is nothing to show that they are definitive.
Je pense qu'il est
I personally think that it lies within the general perspective of science to believe that the world may be made intelligible, that at times it may be controlled pragmatically, but not always, and that to introduce pure chance is to radically wreck the possibility of the full intelligibility of the world. And consequently, I believe we should not accept it.